You must have studied about the planets and the solar system, but did you ever try thinking who gave us a picture of how the planets really work and what is the science behind it? Well, hold on to your seatbelts because now we are gonna go back in time. Before getting into the three laws proposed by Johannes Kepler on planetary motion, let's first look at its history. It all started when Aristotle understood that Earth was round, but he believed that the Earth was at the center of everything, with 56 spheres rotating about it, where the outer sphere contained the fixed stars and the inner sphere contained the moon. Then, 500 years later, Ptolemy, the last of the great Greek astronomers, compounded the confusion. He proposed that the Earth's axis tilts, but did agree with Aristotle's planetary system. The Ptolemaic system is a geocentric cosmology, that is, it starts by assuming that the Earth is stationary and at the center of the universe. However, the paths of the Sun, Moon, and the planets as observed from the Earth are not certain. Then came Nicolaus Copernicus, who formulated the modern model of the universe called the heliocentric system, where helium means sun and centric means center. This theory was proposed in the book written by Copernicus called On the Revolutions of the Heavenly Bodies, where Copernicus proposed that the Sun was at the center of the solar system and that the planets revolve around it. Tycho Brahe was also critical of the observational data that Copernicus built his theory on, which he correctly considered to have a high margin of error. Instead, Tycho proposed a geoheliocentric system in which the Sun and Moon orbited the Earth while the other planets orbited the Sun. Galileo's observation of Venus had proved Copernicus' theory correct. Using his telescope, Galileo found that Venus went through phases, just like our Moon did. But the nature of these phases could only be explained by the Venus going around the Sun and not the Earth. Galileo concluded that Venus must travel around the Sun, passing at times behind it and beyond it, rather than revolving directly around the Earth. Galileo's observations of the phases of Venus virtually proved that the Earth was not at the center of the universe. Then comes the hero of our story, Johannes Kepler. Kepler was assigned the task by Tycho Brahe to analyze the observations that Tycho had made of Mars. Of all the planets, the predicted position of Mars had the largest errors and therefore posed the greatest problem. Tycho's data were the best available before the invention of the telescope, and the accuracy was good enough for Kepler to show that the Mars orbit would precisely fit an ellipse. Kepler's first law. In 1605, Kepler announced the first law of planetary motion. The first law states that planets move in ellipses with the sun at one focus. This law is also called as a law of ellipse. The sun is our one focus and the planets follow the ellipse in the orbit, meaning that the distance of the planets and the sun is constantly changing as the planet goes around its orbit. Kepler's second law. In 1609, Kepler announced the second law of planetary motion. The second law of motion states that the imaginary line joining a planet and the sun sweeps equal areas of space during equal time intervals as the planet orbits. This law is also called as the law of harmony. So basically, the planets do not move with constant speed along their orbits. Rather, their speed varies so that the line joining the center of the sun and the planet sweeps out equal parts of an area in equal time. The point of nearest approach of the planet to the sun is termed as perihelion, and the point of greatest separation is aphelion. Hence, by Kepler's second law, we can say that a planet is moving fastest when it is at perihelion and slowest at aphelion. Kepler's third law. In 1618, Kepler announced the third law of planetary motion. The third law of motion states that the squares of the orbital periods of the planet are directly proportional to the cubes of the semi-major axis of their orbits. This law is also called as the law of periods. Now, for those who don't know what semi-major axis is, it's just the distance from the center of an ellipse to the farthest point of an ellipse. Kepler's third law implies that the period for a planet to orbit the Sun increases rapidly with the radius of its orbit. Thus, we find that Mercury takes only 88 days to orbit the Sun, whereas the Earth takes 365 days to do the same. Hence, we can say that by Kepler's third law of motion, p squared equals to a cube.